All right, where did I put that? Good grief. I can't find anything in here. I don't know. Oh, crap. Okay, this is the first in a series of videos that I'm going to be teaching you how to do modular arithmetic. I'm going to start off very basic. And we're going to remain calculational as much as we can, although I will show you why it works in understandable terms. This is going to be a trial for me because the first time I ever saw modular arithmetic was in abstract algebra. And in abstract algebra, the emphasis is on the word abstract rather than on the algebra. And so just hang on. I'm going to begin by showing you an old-fashioned method of simplifying arithmetic called casting out nines. Once upon a time, many years ago, before calculators were as prevalent as they are now, people still had to do arithmetic. And they would look at a number like this, and they would want to do something with it, like factor it or something like that. And the question would come, is this divisible by a particular number? And one particular thing was, is it divisible by 9? Well, you look at it, well, you would, today we would say take out a calculator and do it. At that point, they had a trick. It was called casting out nines. And so this is how it would go. Take a look at the number because I'm going to dirty up that number. You go through the digits and you say, well, is there a 9 in it? Yes, here's a 9. Get rid of it. Okay, well, are there digits that if you add them up that they're equal to 9? Well, hey, a 3 and a 6, they would add up to 9, so they're gone. Hey, I've got a 4 and a 5, they're gone. I've got a 2 and, well, a 2 and a 7, they're both gone. And when I'm done, okay, when I take out all of those that can pair off and add up, I then add together the remaining digits, okay, to see if they add up to 9. And here I don't have that many digits left, and so I add them up and I get them equal to 1. Okay, so since this is not 9 and it's not 0, I'm going to say, hey, this is not divisible by 9. The only way that such a thing would be divisible by 9 is if there were a 9 or a 0 left at this point. Okay. Now, let's just to take the mystery out of it, I'm going to show you something. I can say this is 9, 4, 7, 3, 6, 5, 2, 1. This is equal to 1052628 times 9 plus 1. Okay. And the fact that this is a 1 here and this is a 1 here is not an accident. Okay. Well, let me show you a different number, and I'm going to say this has 4725. I'm not being quite as ambitious on this one. And here, yeah, you could look at this and pair it up. I'm going to go through this one in a kind of a more systematic way. I'm going to take what's called a digit sum. Okay, 4 plus 7 plus 2 plus 5. And this is going to be, okay, 4 plus 7 is 11, plus 2 is 13, plus 5 is 18. Okay, so the digit sum is 18. Now take the digit sum of 8. 1 plus 8 is 9. Okay, so this is equal to 9. And so I'm going to say here that the number is divisible by 9. I'm going to okay, let's take a look. Don't take my word on it. Okay, turn my calculator on, and I would say 4725 divided by 9 is equal to exactly 525. So 4725 is 525 times 9. And so I knew it was divisible by 9 to begin with, and so I could do it without fear of it not coming out even. Okay. Now, so this is the on the ground, boots level of casting out nines. In the next bit, I'm going to take you a little bit deeper and show you why this works, a little bit of the machinery behind it. Okay, I'm talking about reduction mod 9, and we can actually, any counting number, 1, 2, 3, 4, any positive counting number can work in place of that 9. But we state it when we're talking about division, about reduction mod anything. This is coming from the division algorithm. The idea, you take your number x, and your number x, you divide it by 9, so you get 9 times some number n plus r, where r is a positive integer that's less than 9. Okay, so r is your remainder. Okay, we're interested in what that r is. Okay, we're not so much interested in this n right now. We're interested in what that r is. It's such an important thing that computer languages have it. In Python, we denote it. We would say r is equal to n with percentage sign 9. And we read that percentage sign as mod because that comes over from the way we deal with it in number theory. We'll say r is equal to n mod 9. Now, it comes handy to us now in handwritten work. I'm going to say r is equal to x mod 9 just by putting the bar on it. By putting that bar on it, I'm telling you, okay, go through one of these procedures here and find your r. Okay, now let's take a look here to get some examples for it. Like, say, if we have 11, take it mod 9. Well, basically you just subtract 9 from it until you get down to be less than 9. So 11 mod 9 is going to be 2, and I'll leave the bar over it because that will come in handy to us. Like, what if you have a number that's already below 9? Well, it stays the same. Okay. Now, so what do we have here? Well, let's think of, say, 33. This is more. This is more complicated. Well, what's 33? Well, 33. You subtract 9 from it. Oh, well, let's that hurts my head. 33, that is 3 times 9 is 27. Subtract 27 from that, and you get 6. So 33 mod 9 is equal to 6. I want you to notice something else, though. This is very important. If we take 33, it's equal to 3 times 11, and that's 3 times 11 mod 9. So this is 3 times 2, which is 3 times 2, which is 6. Okay, so our taking something mod 9 is respected by multiplication. Let's try something else here. Let's say, what if we have, say, 13. 13 is equal to, let's see, 11. Well, I'll do a better example. You can tell I'm making this up on the fly, can't you? Let's say 14. Not much different. 14 is equal to 11 plus 3, which is, okay, 11 plus 3, which is 2, okay, plus 3, which is 5, okay. But 14, if I take 14 and subtract 9 from it, we can tell it's 5 right away. So taking mod 9, or in fact in any number, taking mod any number respects both multiplication and addition. All right, let's take a special case here, 10 to the n mod 9, and we have 10 mod 9. This is going to be, well, again, just subtract 9 from it. That gives you 1. Okay. 100 mod 9. You can say, okay, do this in your head. Say 11 times 9 is 99. So that leaves a remainder of 1. And so this is also equal to 1. And then you say, spot a pattern, guy. You take 10 to the n mod 9. This is 10 times 10 n times, which is going to be 1 to the nth power, which is 1. Okay, so 10 to the nth mod 9. Okay. Is equal to 1. Okay, so that's useful for us. Let's put a pin in that for about a second. All right, let's go back to our original example and watch the wheels turn a bit. What I've done here is I've written my original number as a polynomial in 10, which means, okay, I have 9 times 10 to the 7th plus 4 times 10 to the 6th, etc. Okay, and now I'm going to take the whole number mod 10. Well, since modulo respects addition, we can do this a term at a time. Reducing 9 times 10 to the 7th mod 10. Okay, this will be 9 times 1, right? Because all powers of 10 are equal to 1 modulo 9. So 4 times 1 plus, okay, 7 times 1 3 times 1, 6 times 1, 5 times 1, 2 times 1, and then at last just 1. And multiplying times 1, that's still the identity. So this means I'm just adding up the digits. 9 plus 4 plus 7 plus 3 plus 6 plus 5 plus 2 plus 1. Okay, now here is where I need to be careful, right? 9 mod 9, that's just ridiculous. That's 0. 4 plus 7, okay, that's 11. Mod 9, that's 2. 3 plus 6, okay, that's 9. That's 0 again. 5 plus 2, that's 7 again. That's 7. Plus 1. And then I have, 2 plus 7, that's 9, that's 0, and all the other zeros there, plus 1, and again, this brings me down to 1, and we saw before that is what the remainder of this divided by 9 is. Okay, so I'm going to stop right now, and there will be another video where we kind of expand on this modular arithmetic notion. So that was the first of these videos on modular arithmetic. I hope you learned something. Subsequent videos we will tell you more about why this works. If you would like something changed, please tell me about it in the comments. If you like it, give me a thumbs up. If you really like it, subscribe. I'll see you in the next video. Bye-bye. Yeah, who is it? No, I'm not doing anything. Come on in.